Hello everyone. In this video we're going to do some exercises in product rule. So first and then we're going to start with this exercise where we can obtain information out of the graph. So as always, we're going to be able to find what the derivative value is in these lines by finding the slope of the different lines. So similar as I showed before, you can get the slope of lines by analyzing the values in two different points. So for example, I can go with 1, 2 and 0, 0. And so with that, I'm going to know that the slope of this is 2. Similar with this, I can know that the slope of this is going to be minus 1/2. And in this scenario, is going to be 1/2. And in this scenario, is going to be minus 1. Remember, we can check the slope over two different points. For example, 5, 2, 6, 1. Make the difference between the y values, make the difference over the x values, and do the ratio of this. Okay, so remember, the slopes comes from this formula, and we take those 2 point y's, 2 point x, and we work with those. Okay, so the interpretation of that is that we can get the tangent lines to get information on the derivatives. So if we're finding out here f prime of 1 times g of 1 plus f of 1 times g prime of 1, which is pretty much the product rule of this function on x equals 1, then we need to find what is the derivative in 1, which in this case will be 2 for f. And g of 1 is actually going to be 1.5. F of 1 is going to be 2. And g prime of 1 is going to be the value of the slope, which is 1/2. So this is 3 plus 1 equals 4. Now similar here, notice that this is a product still, f times g prime 3. So this is still a product rule, f prime and 3, g of 3 plus f of 3, g prime of 3, following the product rule. Now, what is f prime in 3? So if I go here in f and I look at 3 over this line, so f prime of 3 is going to be minus 1/2. G of 3 is g evaluated here, which is going to be 2.5. F of 3 then is the image of 3 here, which is going to be 3.5. And now g prime of 3 is over this line. And so that means that the slope of that is 1/2. Okay. So with that is enough to obtain the value. This is going to be 0.5. Now similar here with the volume 5. At this point, you understand that this is f prime of 5, g of 5 plus f of 5 times g prime of 5. And then you can check in every single of those values. So 5 here, f prime, it gives me the slope minus 1/2. G of 5 is 2. G of 5 is 2. F of 5 is going to be 2.5. And g prime of 5 is minus 1. It's the slope of that line. So this should be minus 3.5. Alright, and so exactly everything works the same for most of the points. Notice that we're having here x equals 2, but when we try to set up this, we're gonna get f prime of 2, g of 2, plus g prime of 2, f of 2. But f prime of 2 does not exist because this is a peak, and so this value does not exist, and so overall this is not going to exist because one of the pieces does not exist. All right, so in the next question we have f of x is 2 times 4 to the x plus x, and g of x is 3 sine of x. So we want to do the product rule for that. So here we can even find the derivative before we can even set up the formula. F prime of x is just going to be 2 4 to the x, and remember we take the derivative of 4 to the x is 4 to the x times log of 4, and then plus 1. And then g of x is easy, it's just 3 cosine of x. And so now if I do f times g prime, this is just f prime times g plus f times g prime, and that'll be 2 4 to the x log of 4 plus 1 times 3 sine of x, and then plus 2 4 to the x plus x times 3 cosine of x. That'll be the application of the product rule here. Now let's see some more cases if we obtain values from a table. So if we have this f times g prime of 2, you gotta remember that we are doing the derivative first before plugging the value. So that's why we're not getting zeros out of values that looks like constants, right? So this will be f prime of 2, g of 2, plus f of 2, g prime of 2. So I have the product rule first apply, and then I'm plugging into later. Okay, so now f prime of 2 is, I find 2, f prime of 2 is 1. G of 2 is going to be 3. F of 2 is going to be 3 as well. And now g prime of 2 is going to be 0.2. So this is 3 plus 0.6, so this is 3.6. Now it is important not to be confused with symbols, and so in here notice that this symbol here is not the product. This is the composition, so this is not talking about a product rule, this is talking about a chain rule. This is f prime of g of 2 times g prime of 2. Okay, and so here we find g of 2, which is 3. And so at this point we can find f prime of 3, which is minus 1. And g prime of 2, I already know this is 0.2. So this is minus 0.2. Then here we have products in 4 and in 1. And this is actual notation for products. So this is f prime of 4, g of 4, plus f of 4, g prime of 4. Okay, so f prime of 4 is -2. G of 4 is 0.7, as G of 4 is 2, sorry. F of 4 is 1. And G prime of 4 is 0.7. So this is -4 plus 0.7. So this is -3.3. Okay. D is a similar case. It's just in a different order. So we can see this as G prime of 1, F of 1, plus F prime of 1, G of 1. But it's essentially the same things. And so once that I look the values, then I should be able to just find the result. So in particular, this is going to be 0.1 times 1 plus 2.5 times 5. So this will be 10.1. You can verify the values by finding the values of G and G prime and 1, which are 5 and 0.1, and the values of F and F prime and 1, which are 1 and 2. Now let's move on. Move on to the next question. So it is important to know when we're actually using product rule and when we're using chain rule. So in the next question, we're gonna see that we have a couple graph again, and y is equals f of x, but we have that x is equals g of t. The fact that one function is in terms of the output of the other function means that we're gonna be using chain rule in this scenario. The other tell that this is a chain rule is because the output of the first function has a rate of change in terms of the input of the second function. So from that, we're going to see that this is essentially f prime of x of t times x prime of t, right? But x prime of t is just g of t, and x is g of t, so this becomes f prime of g of t times g prime of t. And now if we're evaluating t equals 1/2, then that means that we have f prime of g of 2 times g prime of 2. And now as always, we can get those values from here. So g of 2 is 2, so we get f prime of 2 times g prime of 2. We get the values in the same ways as usual. F prime of 2 is going to be the slope of this line where 2 goes. Clearly, when this is 1, this is 2. So we can get that the slope of this function is going to be 2. And for g prime of 2, g prime of 2 belong to this slope. And this slope is 1/2. As you can see, in 0 is 1 and in 2 is 2. So doing the calculations for the slope, this is going to give me that this is 1/2. Okay, this is 2, this is -1, and so on and so forth. So this is 2 times 1/2, which is 1. Now a similar thing happens when at t equals 4. This is f prime of g of 4 times g prime of 4. And g of 4 is going to be here 3. So this becomes f prime of 3 times g prime of 4. So f prime of 3 is still over this line, and g prime of 4 is still over this line, so still 2 times 1/2, so still 1. Notice that if we extend this analysis to a third one, we do dy dt on t equals 6, then we got f prime of g of 6 times g prime of 4. But when we do g of 6, we're gonna find out that this is 4 here. So this becomes f prime of 4 times g prime of 6. Sorry, 6 here. Times g prime of 6. But f prime of 4 does not exist because it's a peak. So this is going to did not exist. And overall does not exist. Okay, so this is not only one thing that happens only with product rule, but it also can happen with chain rule. Right, and so this is the end of part 1 of the product rule.